this one. Okay, you're seeing the slides notes?
Yes.
All right. So if I'm going too fast at any point or something doesn't make sense, just slow me down because people watching it later will be appreciative for your input. Cool beans?
Okay.
All right.
Yep.
I'm gonna let you get this. Tell me when you got this down, and then we'll talk about it a little bit.
Okay. Okay.
Okay. Do you remember what SOHCAHTOA is?
Yep.
Okay. So sine, cosine, tangent. We're going to be using that. We're going to change it a little bit. Okay. If I'm screen sharing, the initial ray. So it starts at the vertex. This is the initial ray, and a positive angle goes in this direction. So if it's like say it's around 70 degrees, that is positive 70 degrees. If like so, this would be kind of the quadrants. If you have an angle over here, so this is like positive 150 degrees, let's say. So we'll say if this is 150 degrees, this is 70 degrees. When we talk about the reference angle, it's to the closest x-axis. So 70 degrees, the reference angle for 70 degrees is also 70 degrees. But the reference angle for 150 is 30 degrees.
Okay.
Does that make sense?
Yep.
Okay, and that goes for however many times around the circle it goes. If you have you have an angle that goes to like here. Let's say that's 180 and 80. Let's say that's 260 degrees. The reference angle here, use a different color. The reference angle here is 80 degrees. Does that make sense?
Yes.
Now, these are all positive. If we go the other direction, if I go this way, let's say right to 90, that is negative 90 degrees because it's going this way. The reference angle is still 90, but it's negative when we measure an angle going clockwise. Does that make sense?
Yep.
Okay, good. Let's go back to my notes, see if there's something I missed there. Oh, one thing I wanted to say. Change my mind. So I made the note in the slide at the top of 159. There's a mistake. Okay, I want to see this better, clear. But anyways, the diagram is correct. The words are not. It says initial ray is positive. Sorry, rotated clockwise for positive, counterclockwise for negative. That's wrong. It's the opposite. Because it shows right here. This is positive when it goes up, negative when it goes down. Okay?
Yeah.
All right, let's go back to notes. Because everybody loves notes. Wow, my arm looks really disgusting there. Got it?
Yes.
Same terminal ray are coterminal. So if they kind of end on the same spot, they're called coterminal. So 90 degrees, you know what the 90-degree angle is, right? If you go all the way around the circle again, another 360 degrees on top of that 90, it ends in the same spot. Does that make sense?
Yes.
Yeah, you're good? Okay. So make sure. Who is that? Who just joined us?
Jamie Jose.
Oh, welcome here, Jamie Jose. Hello. You missed the first page of notes there, Jamer, but you can still kind of catch up here. It's all being recorded, but like I said to Karina, if something doesn't make sense or you want me to stop, please say so, because that'll help people watching this later as well.
Sounds good.
Cool. Just know there's one page of notes before this. Jamie, are you taking notes right now, or are you just kind of watching right now?
I'm just watching right now.
Okay. Karina, can you tell me when you're done writing?
Yeah, I'm done.
Okay. So, does the principal angle make sense?
Could you explain it?
No, just kidding. The smallest of the positive coterminal angles is called the principal angle, so which is always between 0 and 360. So we talked about like a 90-degree angle is coterminal with a 450-degree angle. I'll show you. Okay, so with my, that looks kind of crazy. But let's say we have, this is a 70-degree angle right here. If we were to go around, I wish I had a different color. Anyways, so if I go all the way around, so that's 360 right here, and then I add 70. So 360 and 70 would be 430 degrees. Make sense?
Yep.
It seems silly. It's like, well, 360, you're done. How do you keep going? Well, you can keep going. So if I go 360, 720, 1080, etc., etc. But anyways, a 70-degree angle and a 430-degree angle, are said to be coterminal because they terminate on the same arm, leg, ray, whatever book calls it. But they terminate in the same spot, which means they're coterminal. The 70-degree angle is the principal one because it is the smallest of the coterminal angles.
Oh, okay.
Okay? There's lots and lots and lots of examples in the textbook. Like today,
That was me.
Oh, hi, Emma. And that's what I talked about earlier. I'll let you write all that down, and then we'll look. I know Karina's writing notes right now. Jamie said she wasn't. Emma, if you are writing these down, like there's a slide ahead of this, but if you are writing this down, can you let me know just so I don't skip ahead before you got it down?
Okay.
But it is all recorded. Well, it better be.
I'm done writing.
You're done? Is anybody else writing or no?
I'm not writing.
Okay, so we'll go off of you, Karina. All right, so reference angle, we talked about that a little bit on the first slide, but let's look at the examples in the textbook. Man, my freckles, that looks like touching. That's on your
Yeah,
screen?
I can see that.
Okay, cool. All right, so here's how these, like, so we learned kind of coterminal, principal, and reference angle, and this is the way they are. So 70 degrees is right there. Is that the example I just used? Weird, that's total fluke. Anyway, so 70 degrees, if you go all the way around, and again, that's 430 degrees, this is the example I was just talking about. So 70 and 430 are coterminal because they end in the same spot. 70 is the principal angle because it is the smaller of the two, and it's also the reference angle because it is the closest to the x-axis. I'm not going to ask if it makes sense just yet. I want to do a couple more, and then we'll see, so you can see what the different ones look like. So 120 goes here. If we go all the way around and then to 120 again, that's 480 degrees. 120 degree angle, 480 degree angle. They're both positive because they're moving in the counterclockwise way. They are coterminal because they end on the same spot. 120 is the principal angle because it is the smaller of the two. And then this space here is 60 degrees. That is the reference angle. The reference angle is the one that's closest to the x-axis. That's the one we need. That the reason we need to know the reference angle is because when we're doing our SOHCAHTOA and kind of solving for sides and angles, it's all going to be kind of positive. And we aren't able to use SOHCAHTOA with obtuse angles, so that's why that's important. Are these making sense, you guys?
Yep.
Yeah?
Yep.
Okay, stop me if it doesn't. Another example, 240 degrees is coterminal with negative 120. So if we're going the other way around, if we go this way, we go clockwise, it's a negative angle. Counterclockwise is a positive angle. 240, negative 120, these are coterminal. 240 is the principal, because we talk about, I said the least, it's the least positive angle of the two. Negative 120 is smaller and lesser, but 240 is the least positive angle. And then when we talk about a reference angle, it's just this terminal arm. You can kind of ignore everything else. Terminal arm, which is the closer x-axis. This one is closer than this one. So then 60 degrees is the reference angle. And when we talk about reference angle, we kind of talk about it in like absolute value terms. When we say this is positive, goes this way, this is negative, goes this way. 60 is, it doesn't matter what quadrant it is or anything, it's the reference angle is always going to be a positive angle. Questions? Hearing none, I'll keep going. Again, please do not hesitate for a second to stop me if something doesn't make sense. So now radians, here's an example in radians. Remember, 180 degrees is pi radians. 2 pi, that's why I see circumference is 2 pi r. 2 pi is 360 degrees. So you'll start learning kind of the shortcuts to how to figure out pi over 3, pi over 2, stuff like that. Pi over 2 is 90 degrees, for example. Pi over 3 is 60 degrees, and so on and so forth. But anyways, the positive angle here, 5 pi over 3, goes to here. Okay? Negative pi over 3, same terminal arm, so they are coterminal. 5 pi over 3 is the smallest positive angle of the two, so that's the principal angle. Pi over 3 is the reference angle. Remember I said before, the reference angle is always kind of absolute value. It's always positive. The distance here is pi over 3, which is 60 degrees for what it's worth, if that helps. So 5 pi over 3 would be 300 degrees. But me just throwing out those numbers, the degree conversion, don't go, how in the heck, what? I don't understand. I'm not. No? All right. For what it's worth, if you want to talk, it's easy. Like if you're on a laptop, I know you can just hold the space bar to unmute yourself for a second if you're muted. Instead of trying to find it, click it, blah, blah, just hold the space bar. On an iPad, I have no idea. All right, so example 1, I think I said I was going to look at. So it says, for the following given terminal rays, and part of the reason we're not doing writing examples today is because there's a million examples and there's lots of notes. We're only about halfway through the notes so far. So I thought we can just refer to the textbook. For the following given terminal rays, name two coterminal angles, one positive, one negative, the principal angle and the reference angle. So first of all, the reference angle is easiest for this one. It's 30 degrees. Okay. Now, if it wants two coterminal angles, so two other angles, one positive, one negative, that end in the same spot. So in this case, 30 degrees, I can just add 360. Okay, so 30 plus 360 would be 390. And all this stuff is done here anyway. Is 390. If we want to go the other way around, that would be negative 330. Okay, because you only have 30 more degrees to get your full 360. So we're stopping 30 short, so that's negative 330. So it's got 390, negative 330. Principal angle is 30 degrees because we just had three coterminal angles, 30 and 390 and negative 330. Those are three coterminal angles, but the smallest positive principal is 30 degrees. Reference is 30 degrees. Are there any issues with that? Hearing none, I will continue. Just note, these are possible answers. Like you could have different answers because all it says is give coterminal angles, one positive, one negative. You could add 720 to this one. You could subtract negative 1080 from this one if you want. Those are all multiples of 360. You can go around a bunch of times. I bet you Calvin would be tempted to like add 3600 to it or something, but all possible. All right. B, using radians, negative pi over 4. Now, just to kind of get you guys to start thinking about conversions, pi over 4, remember pi is 180 degrees. So if we divide it by 4, 180 divided by 4 is 45. This is negative 45 degrees, if it helps. Because you just might think, well, this is Greek. Like I have no idea what is going on. If you kind of ground yourself in degrees, that might help. So this is negative pi over 4. So it wants us to do the same thing. So the reference angle, by the way, is pi over 4. Okay, pi over 4 radians. Pi over 4. We can add 2 pi to this. So it goes around like this to get that coterminal angle, and we can subtract 2 pi. It goes all the way around to go negative as well, which is what they're doing here. Negative pi over 4 plus 2 pi is 7 pi over 4. Or negative pi over 4 minus 2 pi is negative.
Good.
We're good, thank you. Starting to wonder. At least I'm not hearing you guys snore. All right, so let's go back to the notes. I'll let you write this down and then we'll talk about it. Oops, let's back up. There we go. So tell me, if Karina, if you're the only one writing, please tell me when you're done writing. Jamie or Emma, if you guys are writing, let me know.
Okay, I'm done.
You're done? All right. So, firstly, you won't ever see, I don't think, like SOR car TOA, but I just wanted to make this clear because what we are going to be using, like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. This doesn't have a hypotenuse. The hypotenuse is the radius in a circle. So that's what this means. If you have a point on the circle, you know what, let's go to my, stop sharing for a second. If you have a point, you don't have to copy this down, but you can if you want. if you have like a point on the outside of the circle, there is the x component and the y component. So the x value, so this might be, I don't know, 3, and then the y component is 4. The hypotenuse is 5, but that hypotenuse, notice, goes from the vertex to the edge. That's the radius. So that's why when we're starting to talk about circle geometry here, it's going to be over the radius. So when you see, as I mentioned, going to the top of page 161, it's the sine of theta is the y component over the radius. The cos is the x, the horizontal component, over the radius. And then tan is y over x, which would be opposite over adjacent to the angle. So if you're solving for the radius, it's the root of x squared plus y squared. That's just Pythagorean theorem. Okay? Now, there's 3 reciprocal trigonometric ratios. So cosecant, secant, and cotangent. This is not the same, and there's notes coming up. This is not the same as saying cos to the negative 1. You know, if you want to take inverse cos to solve for an angle, that is not the same. Cosine. Cosecant is sine. Secant is cos. Cotangent is 1 over tangent. And 1 over sine of theta, it would be the radius over y. Notice, so sine is y over r. Cosecant flips it, r over y. Cosine, x over r. Secant, r over x. Tangent, y over x. Cotangent, x over y. You will need to, I was going to say you need to commit this to memory, but actually I think this is on the formula sheet. But it just makes it way easier if you remember this. And it's just remembering these two. Remember that they are 1 over, and that cosecant is sine, secant is cosine. We okay with that so far? Stop me if I'm going too fast. I'm not hearing anything. So I think I also said, it shows here, so you can look at this, kind of how to tell when it's going to be positive or negative, what's going to happen. But let me just show you this first to see if this helps. So if, oh, this pencil here. So in a circle here, what do I use first? Maybe red. In the circle, so this is the x-axis, right? Like this is positive x, this is negative x. This is positive y, this is negative y. Make this a little taller. So when this is positive x and positive y, y is going to be positive, x is going to be positive. Okay, so this represents x and y. On this side, x is negative. It's going to be negative, but y is still positive. Down here, they're both negative because we're on the left side. That makes x negative, and we're on the south side. That makes y negative. Over here, though, x is positive when it's to the right. Hi there. And they're quiet. Is this okay? Does this make sense?
Yeah, that's good.
Yeah, cool, good. So what this also means, now remember, so like say for sine, if we have an angle in here, I don't want to draw over this because I like the way this looks, but I'm going to. Let me see if I have a blue marker just to go different. So let's say we're talking about this angle. Oh, brand new marker is kind of beautiful. So this right here, like I said before, if I'm going to use the example 3, 4, and 5, which works, that makes sense. The x value is 3, the y value is 4. So sine is y over hypotenuse, right? Opposite over hypotenuse, y over r. It's going to be positive. Everything here is going to be positive. Sine is going to be positive, cosine is going to be positive, tangent is going to be positive. When you get over here, anything with the x is going to be negative. And because it's negative and a positive, it's going to be negative. So sine is the y value. Sine is positive. Cosine is negative. Tangent, because it's y over x, is going to be negative. Tangent here, where they're both negative, is going to be positive. Does that make sense? Because if you had an angle here, I'll do like -3, -4. This is going to be 5. Sine is opposite over hypotenuse, y over r, negative 4 over 5. The sine of this angle, sine of theta, is negative 4 over 5, or negative 0.8. Cosine would be negative 3 over 5, or negative 0.6. Tangent, opposite over adjacent, y over x, negative 4 over negative 3 would be positive. I know this is lots of information. That's why there's no real assignment today, which you'll find out soonly. And so that's me just kind of breaking it down a little bit, but it's all summarized here. Do you guys want a moment to look at this, to think about this, or should we just keep going? You know what? I'm just going to give it to you. Please look at these charts. Please look in your book. This is page 161. See if any of it doesn't make sense, if there's anything weird. Notice it's giving you the degrees and the radians. Quadrant 1, 2, 3, 4 goes counterclockwise. Have a look at that. I'll give you just a few moments and then see if you got questions or what have you before we keep going. And I just spilled water all over my shirt, but it's okay. You can't see me. Any issues? Any problems? Is this okay? I'm not expecting to have it kind of down and memorized and perfected, but does it make sense?
Yes.
Thank you.
Yes.
Thank you. All right, so we're going to move along. It's another thing to memorize, and I would prefer not memorizing, but to understand. So if you want to use that little ACTS, then you can, but I don't like it. Anyways, so there's lots and lots of examples. We're going to kind of have a walk through, but some important parts to remember. Lots of times when you're given an angle in radians, it'll be pi something. You'll be like 2 pi over 3 or 3 pi over 4, pi over 2, whatever. But sometimes you're just going to be given like 2.68. You're going to be told like an angle is 2.68. And you'd be like, what? If it doesn't have a little degree sign above it, it's in radians. So that's important. Today we're also going to be changing our calculator to radians for certain things. I mentioned this before. Some people will get tempted to use the inverse trig function in their calculator to use, to find secant or cosecant or something. It's not going to work, so don't. Just want to make that really, really clear. Avoid that pitfall. Tell me when you're done, please. Man, I hope this is recording. If it isn't, I'm going to have a temper tantrum. Again.
Yeah, I'm done.
All right. Like I said, there's a lot of examples. So it's 162 to 165. And when you start looking the pages, start looking through the pages, you're going to go like, holy moly. So that's why that's today, is just go through, make sure you're comfortable with the calculator, going radians to degrees and figuring out the proper order of things. I had said before, you can only do the ones that you want to do. And I hate going against that. But I think stuff like this, what we're doing today, you really need the muscle memory, the practice of the order of the buttons and things like that. Everybody's calculator is different. Some you got to put a number in and then hit your trig function. Some you got to the trig function first, and so on and so forth. Different ways of doing it. So it's really good to get the practice in. We're going to go through some of these examples, and it's still recording. Go through some of these examples, and then we'll kind of go from there. All right, look at that. That's beautiful. Look at the color. And goodbye. So, starting page 162. And we're not going to go through all of everything. I'm just going to get you started and get you comfortable, hopefully. So, number 2, it says, find the 6 trig ratios and the corresponding angle given a point that lies on the terminal ray of an angle theta in standard position. That's a whole lot of words, saying a whole lot of things, but this is what it means. And when it talks about the 6 trig ratios, that means sine, cosine, tangent, secant, cosecant, and cotangent. And they're all listed down here, but let's talk about how we got there. So a point that lies on the terminal ray, so it's 4 and 5. That means x is positive 4, y is positive 5. 4, 5, if we want to figure out the radius, r, which is also hypotenuse, but the radius, a squared plus b squared, so 16 plus 25 is the root of 41. So r equals the root of 41. So cos, sine, and tan, cos is x over r, the x value is 4. 4 over root of 41. And then they got the root sign from underneath the denominator, which is really important. So it's 4 root 41 over 41, or you put this in your calculator. And this is no cosine or nothing. This is just the root of 41 times 4 divided by 41 is 0.6247. Cos of theta is 0.6247. Sine of theta, y over r, 5 over the root of 41, 0.7809. Tan of theta, y over x, 5 over 4, 1.25. Don't even need a calculator. Cosecant, which is 1 over sine of theta. So if this is sine of theta, it's 1, where is it? It's 1 over that. Here it does the reciprocal because that's what happens. But you could just do 1 divided by 0.7809, and you'll get this. Secant, 1 over cos theta. We know cos theta is this. 1 over 0.6247 equals this. Cotangent, 1 over tan of theta. 1 over 1.25, 0.8. And then if you want to find, does it say to find, oh yeah, and find the angle. Wait. The angle, oh, it's not asking for it, but to get the angle, this is where you use inverse tan. So with this particular calculator, so let's just do one of these just so you can see. And it's a good idea for you guys to put this into your calculator, make sure you're getting the same answers. So root of 41, so for me, my calculator goes like this. Root of 41 equals that, times 4 equals that, divided by 41, 0.62, blah, blah, blah. Now, secant, 1 over cos theta, so if I just do, and then lastly, solving for the angle, it says using tan of theta. You could use any of these if you want, but if we want to use tan of theta, now you're going to be going between radians and degrees. I don't know if you can see that, but mine's on radians right now, and you're going to have to go back and forth. So how do I do it? So make sure you change it when you need to. So I'm doing degrees, so it's 1.25. Actually, it'll be probably second tan. Yeah, 1.25. 51.34 degrees. Do try these. Do punch some of these into your calculator to get the idea. Same thing over here, except because it's in this quadrant, cos is negative, sine is positive, tan will be negative. Cos is negative, sine is positive, tan is negative. Because it's in this quadrant. You've got negative 3 and 7. It's always x then y. Negative 3, so 3 to the left, up 7. So 3 squared plus 7 squared, the root of that is going to be your hypotenuse, the root of 58. All this stuff is the same, except, here's the tricky part. If we're using tan of theta, so 7 over 3 here, if we're talking about the reference angle, where it's just 7 over 3, you're going to get 66.8 degrees. That's the reference angle. So to get the angle, because it's this, it's 360 minus the 66.8. Because the 66.8 degrees is the reference angle. Any questions? There's a little bit more I want to go over before I end this, before I end your suffering. No questions?
Wouldn't it be 180 minus 66?
What did I say?
360.
Yeah, sorry. Yeah, you're right. Sorry, 180. Thank you. Yeah.
Okay. Yeah.
Good thing you said that. Um, Number 3 is more of the same. Yeah, it's more of the same. It's telling you though, it's telling you cos of A, so the angle cos is root of 5 over 3. What that means is that's the x value, that's the hypotenuse. It's not giving you the y value, so you'll have to solve for that. So a squared plus b squared equals c squared. In this case, c squared minus a squared equals b squared. So 9 minus 5 is 4. The root of 4 is 2. So y is 2. But because it's in the fourth quadrant, it's negative 2. Because it's below the x-axis, it's negative 2. Moving along. Using a calculator, find the answers to 4 decimal places. So this, it talks about the keystrokes here, but it depends on your calculator. You see the degree, so we're going to put this in degree mode. So sine of negative 225. For some of you, you might have to put in like negative 225 and then hit the sine button. My calculator doesn't work that way. So I'm going to hit sine of negative 225, 0.707, which is 0.707. Okay? Now notice here, well here it's telling you it's in radians and not in degrees. But look, it just has a number, 2.0944. If there's no degree sign, then it's in radians. But it's telling you that. So shows you kind of what to do, shows you those answers. So I'm going to kind of leave it there. Do these. Punch these in. Get used to, and make sure you're changing from degree mode to radian mode. I have a little D there. It'll show a little R when I change it to radian mode. Figure out how to make those changes. For some, it's like there's a DRG button somewhere. You just hit those. For mine, I had to hit the mode twice, and then it's degrees, radians, gradients. We'll never deal with gradients. So hit the 2 to go into radian mode. And now if I was to do sine of negative 225 equals 0.93, that's not the answer because I'm in radian mode. It's going to give me a different answer. All right. I think
when do you have to be in the different modes?
You have to be in
like how do you know which one to use?
Degree mode when there's degrees. So this it shows the degree sign, radians. This one's in radian mode.
Oh, okay.
Okay, this one it doesn't have. I kind of wish it didn't have the rads there, but this you got to be careful because you just see 2.0944. You think, oh, it doesn't say pi in it, so it's going to be degrees. It's not because there's no degree there. There's a degree there, so it's radians, degrees, radians, and here it'll tell you too. Does that make sense?
Thanks.
Yep.
Yep.
Oh, I want to touch on number 5 really quick. It says using a calculator, find all angles where the angle is between 0 and 360. Positive, notice it's positive between 0 and 360 to 2 decimal places. Sometimes you'll see it'll be between like negative 180 and positive 180. So it's going to be a bit tricky. So here, sine of theta, 0.9613. So you take the inverse to figure out the degrees. It's 74 degrees. That's the reference angle. So what that means... So what that means is with 70, that's perfect. With 74 degrees, let's say it's kind of like this. It's the reference angle. This isn't super great, but 74 degrees, 74 degrees, 74 degrees, 74 degrees. That's the reference angle. So what it wants you to do is find what these possible angles are. The first one, yeah, that's 74. But from here to here, that'll be 180 minus 74. From here to here, that would be 180 plus 74. This is all in degrees. This one here, let's go on the outside, to this one right here would be 360 minus 74 degrees. Degrees. Does that make sense?
Yes.
Yes.
it all started from sine of theta 0.9613. So you got to find all the possibilities. Sorry, by the way, I was talking about all possibilities. That's a positive sign. That's a positive sign, so it's actually just these two because it's positive on this side. If it was a negative sign, if it was negative 0.963, it would be these two. I have a feeling because there's a lot in this lesson that we're going to be kind of going over this for a little bit. See here, negative sign, so it's quadrant 3 and 4. This is positive sign, so it's quadrant 1 and 2. There are, what I want you guys to do for your work today is go through all of these. Okay, the next 2 pages. Notice one of the things I like. So here it says, notice we don't worry about the negative sign until we establish the reference angle and which quadrant the angle must be in. We also don't round our answers until the final stage of presentation. And I think that's a practice in different disciplines in chemistry and stuff as well, physics. Don't round until the end. If you round too soon and keep going, then your final answer is going to be off. Only 2 decimal places are shown in intermediate steps to save printing space, but the entire number in the calculator was used for the calculations. All right, so yeah, I want you to go through all those examples. We'll worry about the assignment on Monday. If you want to go with the assignment, if that all makes sense, you want to do the assignment ahead of time, that's fine, but that's what will be assigned Monday. And while I'm recording, I'll just say this. I forgot what I was going to say. Oh, Monday, I kind of imagine, like I'll still put a Zoom invite and things like that, but I imagine that it'll just be for questions. I won't be teaching anything on Monday. How red my face looks. But I'll have kind of a live Q&A. But between now and then, you want to send questions, go for it. Peace. See you guys. Let me know if you need help. Bye-bye.